Okay, good afternoon, everybody. Um, Welcome to our last lecture of the semester. This is the review for our third exam for this class, IE 4355, Facilities Planning. And we will have our third exam on Wednesday, December the 1st at 3:30, which is the scheduled time for our lecture. The exam will be online, and I will talk about the details in a minute. And it's again scheduled during the hour and 20 minutes that we have typically scheduled for our class. So I got a request from some of you via email in terms of having a space, a quiet place to take the exam, since some of you will be taking an in-person exam just before this exam. So you will not have enough time to go and sit down in a quiet place. So I will make the classroom for the class available if you want to come and sit down there to work on the exam. So the classroom will be available at 3:30. You just need to let me know if you need a computer, or if you're going to bring your equipment, then you should be fine. But if you're planning to come and sit down in the classroom and you need a computer, please let me know. So in terms of the exam, the structure of the exam, we're going to have two sections. Section 1 is 10 questions. Those could be multiple choice or true or false questions. And those are going to be in terms of the theory and the concept that we have discussed during this third part of the semester. And then section number 2, you're going to have 2 to 3 topical problems. This could be short answer, explanation, description, mathematical problems. And that will be section number 2. In terms of the type of problems that you should expect, those should be similar to the ones we have discussed in class, and also the ones that you have seen in the assignments. So if you feel comfortable solving the problems that we discussed in the classroom, and also the problems that you work on the assignments, then you should be ready to take this exam. Remember that its preparation is very important. Even if the exam is online, you're going to have so much time. It's very limited time for you to work on the problems. So if you are not familiar with the concepts and you are not comfortable solving these problems, you will not have enough time to work on the exam. So my advice for you is to go practice these problems, make sure that you understand how to solve them, and let me know if you have questions. Tomorrow I will have office hours from 8:30 to 10:30 a.m. via Zoom. The link is available in the syllabus. And if you can't meet with me during that time, you can also schedule a time to meet tomorrow via email. So send me an email if you need to schedule a time to meet with me outside the office hours. In terms of the material that we will be covered in this third exam, we will start with lecture 9, which is the material handling lecture. So here we discuss different type of material handling equipment. So the most important thing to remember are the different groups of material handling equipment and the difference between them. When would you use some type of equipment? When would you use a different type of equipment? So those are concepts in terms of material handling. Most important thing is for you to remember the differences between the group of equipment, and when would you use a fixed equipment, when would you use a truck, when would you use a conveyor, and so on. And then we transition to lecture 10, in which we cover conveyor models. And we cover 2 different type of models in this lecture. We covered the conveyor loop with deterministic loading and unloading sequences, and also the conveyor loop with Poisson arrivals. So we spent some time in this lecture. We went through some examples and also in the assignment. So again, it's very important for you to go over those concepts and also over those problems. In terms of lecture 11, we transition into warehouse operations. And in here we did different things. We had 2 lectures associated with this material. So in the first part, we went through the introduction, the missions of the warehouse, the functions in the warehouse, receiving and shipping operations, and also the storage operations in terms of storage space planning. And then we also talk about the warehouse layout model, and we cover different ways of planning for the location of supplies inside the warehouse. We talk about fixed location models and also randomized type of models. So warehouse layout models and then storage systems. And then we went through lecture 12, also had 2 parts. So we discussed different ways in which you can locate facilities, and what are the important things that you have to take into consideration when locating facilities. We went through some examples. We explained some practical decisions that were made in the first part of the lecture. And then lecture 12, we went into a specific type of model, which was the one that you saw in the assignment, that you have to solve for a single facility location model. And we were able to formulate that model using operation research, using a linear programming formulation, but there's also an algorithm that you can use to solve the problem, which is very straightforward, and that's what's covered in lecture 12. So this is the material for the exam. We are going, everything associated with these lectures is posted already in the modules. The material handling equipment lectures are there with the video recording. Same thing for the lecture on conveyor models, warehouse operations, and single facility location model. So if you want to go review those videos, those are available. Same with the lecture notes, all of them should be available. In terms of the assignment, I think all the solutions should be posted with the exception of the one that was due today. So I'll be posting that solution after the review. So that material should be available as well. Any questions about the topics or the material that will be covered as part of the third exam?
The mathematical, like, or actual problems we might work. I mean, should we expect the facility location model we did in the last homework?
Yes, that's a good question. So again, any problems that you can expect in terms of the second section, those should be problems similar to the ones that we saw in the assignments. So all those problems can be asked in terms of you solving a problem in the exam. So check on the assignments that were assigned during this period of the semester, starting after the second exam, in which we have problems related to conveyor models. We also have problems with the warehouse operations and also with the single facility location problems. Any other question? And today, after we go through some additional details, I'm going to show you some the solution for the last assignment, and those are typical problems that can be asked as part of the exam. So the next slide is what will be the best way to prepare for the exam. Study the lecture slides, go through the material, make sure that you understand the important concepts, and also that you're familiar with the problems that we're solving in class and in the assignments. You're familiar with them and you feel comfortable solving those problems. I think that will be the best way for you to feel like you're ready. You can sit down, you can solve these problems by yourself, and also you understand the material that was covered during the third part of the semester, then you should be able to do very well in this exam. I will be providing the formulas and tables if any is needed. So I'll be providing those as part of the exam. And in terms of the instructions, the exam is closed book and notes. and I will be posting the exam in the modules in Canvas. So like we did in the second exam, you will have access to the exam. If you go through the modules, you will find the date for the exam, which is November 29. I'm sorry, December the 1st. 29 is today. So and in the modules for the December the 1st, you will see the link to access the exam, and you don't you'll be able to access the exam from anywhere that you have an internet connection. Make sure that you find a good place with a reliable connection so you can work on the exam. And if you're part of the group of students that are going to be taking an exam just before this one, you need a quiet place to sit down and work on the exam. I will make the classroom for the class available for you if you need that space. So you will have that space if you need it. Clearly show your work and formulas using your solution. So that will help me award full or partial credit for the answers. For the multiple choice or true or false questions, you'll be able to answer those using the computer. And for the questions or problems, you will have to upload the file. So my advice, as always, you can work the solution in a piece of paper, and then you can scan it or take a picture of the solution and upload that file to the computer. So as we did for the previous exam, if you prefer to scan or take a picture of all the problem solutions and upload a single file into the exam, that's okay with me. So you have that option. You can upload a single file with all the problem solutions, or you can upload a file for every problem in the exam. You will have the option to upload a single file for each question, but if you prefer to upload a single file with all the answers, you can do that. You can just place it in one of those links to upload the attachments. You will have 10 minutes to upload the files, so make sure that you plan ahead. My advice is for you to start working on the exam at 3:30, and then at 4:50 you stop and you use the last 10 minutes to upload the files into the computer and into Canvas. The exam will close at 5 p.m. Any questions about the instructions for the exam?
No,
And I
sir.
will, yes.
No, sir. Thank you.
Okay, so this information is already posted in Canvas. I will post the rest of the slides after we're finished today. The rest of the slides. Okay, so let's look at this first before we move to the problems. So as I mentioned at the beginning of the semester, the final exam is optional. Okay, so if you decide not to take the final exam, the grade distribution that will apply to you is the one on the right-hand side of this slide, which is the grade distribution with no final exam option. In that case, you will have assignments and lab only will count for 10% of your grade. And then exam one, I'm sorry, this is wrong. We didn't have a project this year. Let me update this.
You had us worried there for a second.
Yeah. Sorry about that. This is from this slide was from the previous semester. So let me fix that really quick. Okay, so this is the right information. I apologize for that. So your your grade without the final is the weights are listed on the right-hand side of this slide. So as you can see, you'll have homework, quizzes, and labs only 10%, and then exam 1, exam 2, and exam 3 will be 30% each. So what I would do is on Wednesday after you're done, I would try to grade the exams, let's say by Thursday morning, and then by Thursday afternoon, or maybe Friday, you would have your grades. So you would have that information available to make a decision. The so you have the final grade using these weights, in which you're going to have 10%, 30%, and 30% for each exam. If you if you're happy with your grade, meaning that you are comfortable with that grade, you don't have to show up for the final. The exam is going to be online, so you don't have to access the final. However, if you think that taking the final is going to help you, then you can go and access the final exam on the scheduled date. If you take the final, then the grade distribution that is going to apply to you is the one on the left side, in which you have 10%, 22% per partial exam, and then 24% for the final. Taking the final will help only a certain group of students. Like, for example, if you have a 78% in your grade, and maybe taking the final and doing well in the final can help you get to the 80 or to 80 something, so you can improve from C to a B. But if you have, let's say, an 81 in your course grade, with the right-hand side scheme, if you get an 81, there's no way that taking the final is going to help you. Like, it's impossible I mean, if you look at the weights, to get from an 81 to a 90. So that's the type of advice that I will provide to you. So you look at your grades and you make an assessment in terms of if it is going to be worth it for you to take the final in terms of improving your grade. So if you feel that's an option that can benefit you, then go ahead and access the final. If you think there's no way that you can improve your grade by taking the final, then my advice is to keep your grade as it is. One thing that I want to mention is, if you don't want to take the final, then don't access the exam because everybody's going to have access to the exam. But if you access the exam, then that means that you're taking the exam. Okay, so I want to make that clear. So if you access the exam and then halfway through the exam you say, I don't want the exam to count, that's too late. Okay, so you have to make that decision before you access the exam. Okay, so I want to make that clear. So if you access the exam, I'm going to get a report in Canvas that you have accessed the exam. So I'm going to count whatever you have answered in the final as part of your grade. So make sure that you make that decision before you attempt to access the final exam. Is there any questions about the grades? Okay, good. So the last thing I have here is the solutions for the assignments, for the last assignment, actually. So I want to go through this, make sure that everybody understand what's going on. And then if you have questions, you can ask me right now. So in this this problem number 2, we have 12 products that are received by a warehouse according to this schedule. So we want to find the storage requirement for dedicated and randomized storage. Okay, so those are two different philosophies. So for one, you are basically, the dedicated storage is planning for every single product. So in this case, we have 12 products, and those are at the top, the labels for the columns. So we have 12 products. And for dedicated storage, we are planning space for every type of product. Okay, so we want to have a space for product one, we want to have space for product number two, enough space for product three, enough space for product four. And that space is going to be only occupied by that type of product under this dedicated storage philosophy. So at the end, you should expect to see a higher requirement in terms of space, because again, for this type of philosophy, we are looking at space for each type of product. On the randomized storage, we don't plan for space for every specific type of product. We plan for space that can be occupied by any type of product. So we plan for enough space in which we can accommodate all the products at any time. So that's a major difference between the two. So when planning for dedicated storage, we are looking at the, for each type of product, we are looking at the maximum amount that was recorded in terms of being available in the warehouse during this 20 time period. So for example, we're gonna go through for dedicated storage, we're gonna go for product number one. We wanna look at the maximum number during this 20 time period, and we want to mark that. So in this case, that would be 45. And then we do the same thing for product number two. So here we have 47. We do the same thing for product number three, 37, 47 again. Product number four, 46. Product five, 46. Product six, 29. Product seven, 50. Product eight, 9 is 50. Product 10, 45. So if I did my search correctly, I have identified all the maximum values for each product in terms of the amount available in the warehouse during this 20 time period. And then in order to get the number of pallet positions that needs to be available, I'm gonna add those numbers. Okay, so that will be 45 plus 47 plus 46. I'm sorry, 47 again. 46 plus 46. It's 49. 50. 48. It's 50. It's 45. So that should be equal to 571. If I did everything right. And then for the randomized storage, what you're gonna do is you're gonna add for every period, you're gonna find the total amount. So that this will be the total from this column, from this column, from this column, from this column. And then after you find the total for each period, you're gonna find the maximum value out of those totals. And that should be equal to 385 pallets. So the maximum number from this column is what you're gonna use to plan for your randomized storage space occupation. Any questions?
No, sir.
Good, thank you. Okay, so the next problem, we have an existing warehouse be used for storage of 6 product families. The warehouse consists of storage space of 20 by 20. Dock 1 has been designated as the receiving dock. While Dock 2 is used as the shipping dock. The area requirement and monthly load rate for each product family are shown in this table. So we have 6 products, we have the area required, and we have the load rate. So the first part of the question is asking to formulate the problem using the model discussed in class. So, so the formulation is here. We go back here. So if you go back to lecture, this is lecture 10, part 2. So the formulation will follow this mathematical model that we described in class. So that's what we have here as part of the solution. This is the model. Minimize from 1 to 6 for K1 to 40, which are the 40 spaces that we have in the warehouse. The summation of PI times DIK times XJK. So that's this objective function that we discussed in class that is trying to minimize the total distance travel. And then we had 2 types of constraints. The one that is in terms of only one product type can be assigned or stored in each storage location queue. So that's the summation from J up to N, XJK equals 1. And then the second constraint is we assign the required number of storage locations to each product. So it's a summation from K equals 1 up to Q of XJK, which will be equal to SJ. SJ, we define SJ as the number of storage locations required by product J. Okay, so the formulation, going back here, that's what we have for the first part of the solution. Turn off the video. And that will be the first part. And then part B is determine the layout that will minimize the total expected travel distance. So again, here we go through the process that we discussed in class, in which you have to find the value or the weight for each one of these spaces in the warehouse. So if you remember that lecture, the value of each cell will be equal to Fk, and that will be the summation from I1 to M of Pi DIK. DIK is the distance and Pi is the probability. So we are assuming that there's the same probability of going in that goes out, right? So we are assuming that P1 and P2 is going to be equal to 50%. So using those values, we substitute that into this FK equation. PI is going to be 50% or 0.5, P2 is going to be 50%. And then we have to compute the distance from each door to the location of the cell. And those are going to be rectilinear distances, right? So we go from each one of the docks and we compute add up the distances until we get to the centroid of each cell. So that's what we did here in order to get the cell values in this solution. We went through that process, and I did I colored the cells according to the distances. So the light blue is showing the shortest distances to travel distances, or the shortest travel distances. And dark blues are showing an increase until we get to 170, which is the corner, the top right corner of the facility. So once we identify all these distances or weighted distances, now we need to assign products to each one of these cells. So the way we are going to assign those products is based on these ranking that we do based on the TJ by SJ ratio right here. Okay, so we are going to allocate first those products that have a high ratio of TJ over SJ. So if you look at the values for this column, the one that has the highest ratio is product 6. So that means product 6 goes first, and then follows 160. So that means that product 3 goes next. Then follows product 1, and then product 4, and product number 2, and then product number 5. So we're going to start allocating these products according to these ranking. So we're going to start with product 6. And as you can see, product 6 requires these many bays, 6 bays. So we're going to allocate those in the best location in the warehouse. I'm sorry. We're going to start with product 6. And that product 6 requires 4 bays in the warehouse. So in my solution, I place those here, here, and here, and here, because those are 70, have an F value of 70. But that doesn't mean that's the only place in which you can put product 6. You can put product 6 in any cell that has a value of 70. So you can put them anywhere here, 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 as long as you occupy 4 of them, then the solution is okay, or the solution is correct. Okay, so the important thing is that you place them in the best location in the warehouse, because they are ranked first based on our method. And then after placing product 6, we go to product 3, and for product 3 we need 8 bays. Okay, so if you see here, for product 3, product 3, we require 5. I'm sorry about that. I'm getting confused with these numbers. We need 5. So 1, 2, 3, 4, and 5. Again, there are the second in the rankings, so we put them also in these cells that have the best values, which has a value of 70. And we still have 3 available, so we can put the next product also in these 3 cells. So the next product is product 1. So that means that we can put 1 in the rest of the 70 value cells. And then we have 3 more. So I can put them in the next better value cells, which are 80. So that's why we have 1 here, 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 and that makes 6. So we are done with 1. Then 4 follows. So for 4, we need 7. Okay, so I'm gonna use the 80 cells, 1, 2, 3, 4, then follows the 90. And then we have a couple of hundreds here, so that makes that 7. And you understand the process now. So you follow this procedure, you allocate the next product in the ranking in the best position in the warehouse based on these values in the cell until you complete the process of placing every single product into the warehouse. So the final solution should include the values for the cell and also the location of the products based on those cell values. Any questions? One question that I typically get is, how do you know how many bays are needed per product? The answer, because we are only given the area. So how do we know how many cells are needed per product? Well, we know that each cell is 20 by 20. Right, so that's 400. So we can divide, for example, for product family 1, it's going to be 2400 divided by 400. And that will give us 4 times 6 cells. And that's what we have here. And we can do that for every product. So in the exam, you are not given the number of cells that are needed or that SJ value. You can find that value by looking at the size of the cell and also the area of the warehouse that is needed for each product. And then the final problem is for the facility location. So we have the Ashley County News Observer plans to rent building space for a new print shop within the city limits. The locations for current distribution centers, expected deliveries, and possible locations for the facility are shown in the tables and figures below. The question is asking to determine the optimal location for the new print shop. And we have the current distribution centers. So for each center, we have the X coordinate and the Y coordinate, and we also have a weight associated with the amount of interaction that each center is going to have with this new facility. So for example, F has a very high weight, 600. So that means that F or center F is going to have a very high interaction with this new print shop. And so in order to solve this, we can apply operational research, linear programming, and solve the problem using the simplex method, but that's not what we want to use. We want to solve the problem using this algorithm in which we compute the weight threshold by looking at the summation of the weights and divided that by 2. Okay, so the summation of the weights and multiplying that by 1/2 or dividing the summation of the weights by 2, that will give us a threshold value. In this case, that's 1200. So I'm going to use that threshold to make decisions. Okay, so I get the number, and now I'm going to look at each coordinate. And I'm going to sort these coordinates in ascending order or non-decreasing order based on the value of the coordinate X. So that will be, this will be for X and this will be for Y. So if you look at this list, we start with 5, then 15, then 25, then 30, then 35, and then finally 50. So that's the order that we have here, and that order is also linked to the centers. It is also linked to the weights. So as you can see, for A, the coordinate is 5, so the weight is 200. Then the next coordinate is for center E. So the weight for that one is 400. Then the next one is C with 25, and the weight for C is 500, and so on. So after I sort these rows, I want to create a new column that is going to be the summation or the aggregated values of the weights. So you start with 200, and then it's going to be 200 plus 400. That's 600. 600 plus 500 is 1100. 1100 plus 600 is 1700. 1700 plus 300 is 2000, and 2000 plus 400 is 2400. So after obtaining this sum of the weights, I can use this threshold value to identify my coordinate for X. So what I'm going to do is I'm going to find from this list the first value that is greater than this threshold. So the first value that is greater than 1200 will be this one. And that will be the coordinate for X for this new facility. Okay, so X star is going to be 30. And I do the same process with the Y coordinate. I'm going to sort this, and then I'm going to go and look at the summation or the aggregate values for the weights. I'm gonna find the value that is greater than this threshold, and that will be the coordinate in terms of Y. So Y star is gonna be 20. And that will be the solution for this problem. The location of this new facility based on this method is gonna be coordinates X equals 30, Y equals 20. Any questions? Okay, so that's the last problem that I have for discussion. I now open the review for questions, specific questions from the students. If you have any questions. If you don't have questions, again, you can, yes, go ahead, Eric.
I was just going to say thank you for allowing us access to the classroom. I appreciate it.
Awesome. Yes, so that's already planned. So you can, if you need to, you can just go to the classroom directly, and I'll be there.
All right.
Okay, so I will be posting this review video and the notes after the class. And again, tomorrow I have office hours. So if you want to meet with me during my office hours, you're welcome to do that. Or if you need to set up an appointment on a separate time, you can do that as well. And let me know if you have any questions via email or during my office hours. And if you don't have questions, then I'm gonna stop sharing my screen, and then I will talk to you soon. Bye-bye.
Thank you.
Thank you. Bye-bye.